Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge. And the problem is search a 2D matrix 2. Write an efficient algorithm that searches for a value target in an m cross n integer matrix. This matrix has the following properties. Integers in each row is sorted in ascending order from left to right, and integers in each column are sorted in ascending order from top to bottom. What it states that is in the given matrix, for if you consider in each row, the elements will be sorted from left to right, and if you consider each column, the elements will be sorted in top to bottom fashion. So we have, and we are also given the target. We have to find whether the target is present in the matrix or not. So what we can do here is we can go for a brute force approach. First, brute force approach. What will be the brute force approach? We will be scanning through whole matrix and we will be finding the whether the target is present or not. The time complexity here will be order of m into n, m cross n, and the space complexity will be order of 1, since we are not using any extra space. So how we can optimize this brute force? If we can want to optimize this brute force, what we can do is, since each row is sorted and each column is sorted, we can make use of that property to find whether our target is present. What we can do is we can traverse each row and we can check for one condition whether the given target present in that row or not. That is, if we can check whether the target is present in between this 1 to 15, or the target is in between 2 to 19, or in between 3 to 22. If we have found that the target is present in that range or in that row, then what we can do is we can perform binary search, and we can if we couldn't perform, if we didn't find the element in that row, then obviously the element is not present in that row. So what we can do is we can go across each rows and we can check for the condition that 5 is greater than or equal to 3 or less than or equal to 22. Then it says that this 5 is present, 5 can be present in this row, present in this range, or 5 can be present in this range 2 to 19, or the 5 can be present in this range 10 to 24. So like that, if we check and we perform binary search on each row, then we can optimize this brute force to better optimal solution. We can say it as optimized somewhat. And what will be the time complexity for this solution? The time complexity here will be, we will be going for each row, so it is order of m cross. We will be performing binary search on each rows, right? So it is log n, so it is m into log n. So for each rows m, we will be performing a log n time binary search, and if the range is between, if all the rows contains the range which is having this target, then we will end up performing a binary search in each rows. So we will be performing for m rows, and finally the time complexity will be m log n. So the space complexity will be order of 1. But can we do more optimize this approach? Can we optimize this also? Yes, we can have an approach of time complex optimized. I will say it as optimized, and we have an approach of order of m plus m, order of m plus n, and the space complexity is order of 1. Why this is optimized to this time complexity is, if we since all the rows and all the columns are sorted, we can make use of this property that if the current element, we will be initializing the row pointer to be 0 and column pointer to be call -1, and we will be checking whether if my target is equal to my mat of row call, then we will just return true. This we can say. Or else what we can say is, else if my target is greater than mat of RC, then we can say that since it is sorted, we can increment our row. Else my target is less than mat of RC. If my target is less than that mat of RC, then what we can say is we can just contract our window. So we will decrement our column pointer. So if we incorporate this idea into our solution, then we will be having the solution of m plus n, and the space complexity is order of 1. So this is what we are going to implement here. Let us initialize int r is equal to 0 and column is equal to col minus 1. We'll initialize row size as matrix dot size, and int col is equal to matrix of 0 dot size, and we will be initializing this. Now we have to just traverse the loop. What we will be saying is, if my row is less than my row and my c is less than my call, then we can go inside this loop and we can check for this condition. If we find this target, we will just return true, or else we will end up not finding this target, we will return false. So we will just run our code. Target, sorry, it is matrix. Now we will run our code. Since it is sorted, we are just doing, I will give a dry run. Consider the target is 5 and we are standing at r is 0 and column is at this point. So 0 to 0 4, we are standing at the matrix of 0 4, which is nothing but 15. See, you can see that 5 is less than 15, so we will be decrementing our column. So we will end up standing here. 5 is 11, so 5 is less than 11, so we will decrement our column. You can see that 5 is less than 7, we will decrement our column. You can see that 5 is greater than 4, so we will increment our row, and we will be finding this 5. So 5 is equal to 5, so we are just returning true. So that's what we are doing. If we couldn't find the element, we will end up reaching the boundaries and we will just return false. So we will just submit our code. It is an order of m plus n time complexity and order of 1 space complexity. Let me see what is the error. Sorry, actually we have done a blunder mistake. It is, C is, we are decrementing the column, right? So it's how it can reach C is greater less than col. So we have to check C is greater than or equal to 0. So we will be decrementing our column, and R will reach the boundary of row, and C is decrementing, so it should reach a boundary of 0. So now we will just run our code. It got accepted, so let us submit our code. It got accepted. Hope you like this video, and I hope you understand the solution from brute force to optimize and then the further optimized. So this is our code for today's LeetCode daily challenge. Let me know in the comments if there are any clarifications to be done. So let me see in tomorrow's video. Until then, bye.